Graphs of the trig functions. So trigonometry plays an important role in calculus, and so we're going to need to know a little bit about the trig functions. And there are 6 trig functions: sine x, cosine x, tangent x, cotangent x, secant x, and cosecant x. And so let's look at the graphs of each of these functions. So first off, we have sine x, and we see that sine x has this wave shape to it. One thing to notice is that sine x has no asymptotes. It's defined for all values of x. It continues infinitely to the right and to the left. It has a period of 2 pi, which means every 2 pi it repeats itself. It makes one full wave going up, coming back down, and back where we started between 0 and 2 pi. Okay, another thing to notice is that sine of 0 is 0, so we're starting at the origin here. We increase until we hit our maximum of 1 at x equals pi over 2. Then we come back down, we hit 0 again at pi, and we hit our minimum at 3 pi over 2. And that's at -1. And then we are back to, at 2 pi, we get back to 0, and that starts the whole period all over again. Up next, we have cosine x. Cosine x has a very similar shape to sine x. We do notice a few differences. First off, there also are no asymptotes, so it's defined everywhere, continues infinitely to the right and to the left. But cosine starts at 1, so cosine of 0 is 1, and from there we go down until we hit 0 at pi over 2. We hit our minimum of -1 at x equals pi, and then back up to 0 at 3 pi over 2, and back up to where we started when we get to 2 pi, and then just repeats the cycle over and over again after that. Okay, a graph of y equals tangent x, and we notice that tangent x does have some asymptotes, and the reason it has asymptotes is because tangent x is sine x over cosine x. So tangent x is going to be undefined anytime cosine is 0. And we saw that cosine was 0 at pi over 2, 3 pi over 2. Out here at 5 pi over 2, it was also 0, so we get an asymptote there. And in the negative direction, we get negative pi over 2, negative 3 pi over 2, and so on. Tangent has a period of pi. Each one of these cycles here repeats itself. We go from the bottom all the way up to the top in a span of pi, and then we repeat it ourselves with the next one and continue that infinitely in both directions. Okay, cotangent x looks very similar to tangent x, but cotangent x is cosine x over sine x. And so it's going to have asymptotes whenever sine is 0, and that's going to be at 0, at pi, at 2 pi, and in the negative direction, negative pi, negative 2 pi. Basically, any multiple of pi, we're going to get an asymptote there. Another difference between tangent and cotangent is for cotangent, each cycle is decreasing, the curve is coming down, until we get to the next asymptote, and then it starts back over at the top and also repeats itself infinitely in both directions. Okay, secant x has this U-shape pattern, and it always repeats itself, one U-shape going up, and then the next one goes down, and then the next one goes up. And our asymptotes happen because secant is 1 over cosine x, which means we're going to have asymptotes whenever cosine is 0, and that's at pi over 2, 3 pi over 2, another one out here at 5 pi over 2, also in the negative direction as well. and this U-shaped pattern repeats itself, it has a period of 2 pi. And finally, we have y equals cosecant x. Looks very similar to secant x, except cosecant is 1 over sine x, which means our asymptotes are going to be where sine x is 0, and that's at 0, pi, 2 pi in the positive direction, and in the negative direction, negative pi, negative 2 pi, basically any multiple of pi. Also has a period of 2 pi to make the U shape going up is from 0 to pi, and then one going down, which is from pi to 2 pi, and then it just repeats itself infinitely in both directions after that.